Water. So basically, hydrogen is present on Earth most readily in after combining with oxygen, and that is known as water. This is the basic need of living organism. All major part of the living organism is made up of water. Human body has about 65% and some plants have much as 95% of water. So it is a crucial compound for the survival of all life forms. Okay, it is a solvent of great importance. Water is known as the universal solvent. Uses of water. Water can be used for irrigation, for indoor houses use, that is for washing, bathing, shower, clothing, and other things, cooking, for irrigation purpose, for lives, for cooking, for bathing, means this is the basic need of life, right? So now physical properties of water. It is a colorless or tasteless liquid. The usual property of water in the condensed phase, that is liquid or solid, are due to the presence of excessive hydrogen bonding between water molecules. Water has a higher specific heat, thermal conductivity, surface tension, dipole moment, and dielectrical constant when compared to other liquid. Okay, it is an excellent solvent for transportation of ions and molecules required for plants and animal metabolism. Due to hydrogen bonding with poor molecules, even covalent compounds like alcohol, carbohydrates dissolve in water. It has the gas. It has the gas phase water is a bent molecule when with a bond angle of 104.5 degree, and OH bond length is 95.7 picometer. Means this is the bent structure of water. The angle between the two hydrogen is 104.5 degree, and the bond length between hydrogen and oxygen is 95.7 picometer. It is a highly polar molecule. In the liquid phase, water molecules are associated together by hydrogen bonding. Density of water is more than the ice. Now, hydrogen bonding in water. Hydrogen bonds are chemical bonds that form between the molecules containing a hydrogen atom bonding to a strongly electronegative atom, because the electronegative atom pull the electron from the hydrogen atom, and the atoms forms a very polar molecule, meaning one end is negatively charged and another end is positively charged. Hydrogen bond form between these molecules because the negative end of the molecules are attached to the positive end of the other molecule, or vice versa. See, this is a water molecule, this is the water molecule, this is the water molecule, and they are combining with each other. Means negative end, blue end is connected with the white end, means this oxygen. And here you can see the same system is there. Negative connect with the positive, and positive connect with the negative. Hydrogen bonding makes water form a liquid at room temperature. Okay, now the hydrogen bonding, because hydrogen bonding is the bonding that is exist between the hydrogen and the combining species. Structure of ice. The solid form with highest density as compared to the liquid is ice. Ice has a highly ordered three-dimensional hydrogen bonded structure. Examination of ice crystal with X-ray shows that each oxygen atom is surrounded tetrahedrally by four other oxygen atoms at a distance of 276 picometer. The bond length between the molecules of water is this. So hydrogen bonding gave ice a rather open type of structure with wide holes. These holes can hold some other molecules of appropriate size interstitially. Okay, this is the structure of ice. This you can have already seen in a movie Frozen. Okay, so generally the ice structure is shown like this. So this is the reason behind that logo of ice, because the structure is the structure of ice is like this. Chemical properties of water. First, water is amphoteric nature. Amphoteric nature means it can combine with acids, base, as well as anything. So it behave like an amphoteric substance. So in Boston senses, it acts as an acid with NH3 and a base with H2S. So H2O react with NH3 gives OH negative and NH4 positive. H2O with H2S give H3 positive and HS negative. The auto protolysis or self ionization of water takes place as following, like H2, one acid and one base, means same molecules can be acid base. How? Because of the acceptance or donation of the H positive ion. So H3 positive and OH negative will form. Okay. Next, redox reaction involved in water. Water can be easily reduced to dihydrogen by highly electropositive metals. 2H2 plus 2Na gives NaOH base plus H2. So it is the great source of hydrogen. Okay, when water combined with the Na sodium, it produces the dihydrogen after breaking that hydrogen and OH bonds. Okay, water is oxidized by O2 during photosynthesis. We know the photosynthesis reaction 6CO2 plus 12H2O gives 6C plus H12 plus O6 plus 6H2O plus 6O2. Okay, with fluorine also it is oxidized to O2. When we react this thing with fluorine, this water with fluorine, so what happened? 4H positive fluorine and oxygen atom will form. Hydrolysis reaction, due to high dielectric constant, it has very strong dehydrating tendency. It dissolves many ionic compounds. However, certain covalent and some ionic compounds are hydrolyzed in water. Means this P4O10 can hydrolyze in water. SiCl4 hydrolyze with water and gives SiO2 and HCl. N3 negative react with H2O and form NH3 and 3OH negative. Okay, so this is the hydrolysis method. Why we, at this time we add different compounds to dissociate the ions of water into H positive and OH negative. They just combine with other elements and form new compounds, right? So a hydrolysis process will be like generally this thing. This is sucrose and this is this is sucrose and this just what happened? They just sucrose break down into glucose and fructose. Okay, means when we dissolve sugar in water, what happened? The sugar disappears and it disappears and form glucose and fructose with the same chemical formula, but the structure is different. Okay. Now, the hydrate formation. From aqueous solution, many salts can be crystallized as hydrated salt, such as dissociation of water is of different types. First, coordinate water, this we can form. Second, interstitial water, this is BaCl2, 2H2O, hydrogen bond water, that is CuH2O4, S positive, SO4 2 negative dot H2O in CuSO4 dot 5H2O. Okay. Next is hydrogen peroxide. Sorry. Next topic is treatment of water. Water exists on Earth in different forms. It is hard, it is soft, it is saline. Different types of water is there. But for use, we used to remove the hardness of water. We have to remove it, otherwise it will affect us. Okay. So first we'll understand what is hard and soft water. So water is readily give a leather with soapy soap, not detergents. It described as soft water. Whenever we mix detergents in water, it just produce some leather, some form. But that shows that that water is soft. But in case of hard water, it does not happen. It does not dissolve properly, or either if it dissolve, it does not produce any leather. So hard water means the water does not readily give good leather with soap and so we soap as well as causing the scum, though the hardness does not affect the soap less detergents. Okay, so hot waters come in two varieties. Okay, first is temporary hardness and second one is permanent hardness. So temporary hardness is the type of hardness caused by the presence of dissolved bicarbonate minerals, calcium bicarbonate and magnesium bicarbonate. When dissolved, these minerals yield calcium and magnesium cations and carbonates and bicarbonate anions. So they affect the temporary hardness can be softened by boiling. So there are different methods to remove the hardness. Okay, so that happens in this way. When boiling magnesium carbonate and calcium magnesium carbonate cannot be removed. Okay, large scale of particularly what unsafe, unfeasible. For example, the calcium bicarbonate, when we heat it, when we start boiling, what happens? It just precipitate in the form of calcium carbonate. CO2 will liberate out and water left behind. What happens actually when you see these types of arrow? This means it gets precipitated, and this is CO2 which gets liberated out. So whenever in winter season, what happened? We used to boil the water to take bath, to take shower. So what happened on the boiler tube? You will see some hard substance will deposit on the tube. That white substance. So that thick and hard substance is the calcium carbonate, which just deposit on that rod when we boil the water. Right. Second, add of lime of hydrates, and lime is added to the water. Calcium carbonate and magnesium hydroxide get precipitated. What happened? Magnesium carbonate, hydrated lime will add it to this. So magnesium hydroxide will form, means it get precipitated, and calcium carbonate also get precipitated and water left behind. Magnesium bicarbonate, hydrated lime, and the same happened, and magnesium hydroxide will precipitate. Same when this calcium bicarbonate again heated, again hydrogen lime treated with hydrogenated lime. What happened? This hydrated lime just form calcium carbonate, which gets precipitated, and water gap will left behind. So now method of removal of permanent hardness. Lime soda, a base exchange process of zeolite process, and demineralization process. So soda lime process, lime and soda ash are added to the water. Calcium carbonate and magnesium hydroxide (PPG) precipitate are formed and sedimented out in a tank. The carbonate hardness is removed by lime. Non-carbonate hardness is removed by soda. So there are different processes. First, carbonated hardness of Ca. Add lime, this will precipitate. Same with this, again add lime, the calcium carbonate will form, and same, you again treat with this. So there are different types of method which we can use. So lime is the basic thing which is used to remove the hardness of the water. Okay, so this is how we used to this delhi gel board, they used to purify the water. This is a type of tanks in this, where the water is treated with lime and soda, then coagulate pressure will be there, then agification, the reactor tanks, and after that the chlorine tablets added the last, and filtration. There are so many processes and number of steps will be there. Okay, there are the steps. So lime we have studied. So calcium chloride, when treated with soda, what happens? Calcium carbonate form and NaCl form. It can be removed by boiling of the water. CaSO4 react with the soda again, calcium carbonate will form and Na2SO4 will be formed. This will further again treat with the soda or lime, and we will obtain the pure water. Okay, bicarbonate process. In lime soda process, a little quantity of calcium carbonate and magnesium hydroxide remain as final divided particle, and may cause the tubules by getting deposits of the filter to cause enlargement of the sand gains, like incrustations of filter media. For examples like calcium carbonate plus CO2 plus H2O, it gives the sodium calcium bicarbonate. Okay, and this magnesium oxide and magnesium carbonate will further react, and they will form the carbonate hardness of magnesium. Okay, and when these further react with the lime, and after that we will obtain what? Pure water. This is the filtration type, the recarbonation plant. In this there are so many filters, so many things which are used to purify the water. Okay, how this thing happened? The raw water come first, it start boiling, next this go to the lines, and where the we used to collect the water. Next to steel chamber, there also some moisture absorber is there, and so many things. Next CO2 compressor is there. After that the diffuse pipe is there, where you can like carbonated chamber when arranged for the entry and exit of the water recombination. So there are so many processes which are used to remove the hardness of the water. Okay, how water softener works. So there are so many things, so many instruments now there. So what happened, hard water get into it, and the water soften use an ion exchange resin to remove the hard water minerals from the water supply. During the ion exchange process, the hard water ions become trapped onto the resins, and they exchange for sodium ion, create the soft water. Water enter into it, it goes down, and the ions, or the sodium ions or hard water ions, they just absorbed by the resins which is inside that tumbler, and the soft water come out of the outlet. This is how the zeolite method work. Okay. So for the purification of water by the zeolite soften, the hard water is passed through the zeolite bed as the specified rate. The hardness causing ions such as Ca positive, Mg positive are retained by the zeolite bed as CaZMeg respectively, while the outcoming water contains sodium salts, and the following reactions takes place. This is how the hardness removal. This is the method of removing the temporary hardness. This is the method of removing the permanent hardness, and this is the regeneration of zeolite bed again. Because what happens is used zeolite react with the brine solution. What happens? We'll again get our pure zeolite, and the washing soda, the washing like the things which just absorbed by that zeolite will remove out of it, and we'll get it. This is how the resins look like after osmosis. What happens? They just absorb the ions, trap the ions, and help in the removing of the hardness of the water. This is how the zeolites often work. The hard water get into it. Okay, it gets sprayed inside it. What happened? The zeolite bed just absorbs the things, the ions or something. It's just when it get passed through this thing, it just passes through the pipes, and after filtration from these gravels and zeolite bed and so many things, it's just the soft water get come out of. Okay.